Hi guys, welcome to tutorial 2, video question 3. Let's do this. As always, I want to put the question right down here. Again, like always, read it over. Pause the video, read it over, attempt it yourself, and then we'll go through it together. Alright, so let's think about it this way. Well, we're going to start with our base case. Of course, we're going to start with our base case. If P has 0 occurrences of the t value or the true value, then P is false, right? But if P has odd number of true values, in this scenario it's 1 false because it can't be more because P is just 1, right? Then P is true as required. That's it. That's the base case. Next, as we know it, we're going to do our inductive hypothesis. Well, the fancy word for the assumption. We're going to say, and we're going to actually do it twice. We're going to say S1 is true if and only if an odd number of its variables is set to true. That's the first one we're going to make. And we're going to make the exact same thing for S2. And, we're going to assume that that's always the case. And the next step would be to prove that S1 XOR S2 is true if and only if, remember that part, an odd number of its variables is set to true. Again, remember the if and only if section. Now, why do I focus on that if and only if section? Well, if you remember from MAT 102, mathematical proofs, and for some of you guys who don't, when we say if and only if, that means when you say the sentence one way and then backwards, it still stands true. Okay, let me tell you what I mean. So the question, what we want to prove is that S1 XOR S2 is true if an odd number of its variables is set to true, and if an odd number of its variables is true, then S1 XOR S2 is true. Now, if you need a little refresher how these two things are different, MAT 102 notes, go for it. If you need it, let me know. I'll definitely send it out. But we need to prove those two things. We need to prove both of those two things. Let's start with case 1. If S1 XOR S2 is true, then an odd number of its variables is set to be true. Okay. Let's dissect that a minute. If S1 XOR S2 is to be true, then exactly one of them has to be true and the other one has to be false. Why is that? Well, look at the table inside the question. There is no case where that combination can be true if both of them are false or both of them are true. So one or the other has to be either true and the other one has to be false. That's just the case. Now, based on our inductive hypothesis, if one of them is true, that means one of them has to have odd number of variables, and if one of them is false, that means the other one has to have even number of variables. Okay, great. So we know that this thing, there's an odd plus even. Okay, odd plus even is what? It's still odd. So it stands true. S1 XOR S2 will have an odd number of its variables set to be true, and based on our dissection. And following case 1, we got to prove case 2. If an odd number of variables is true, then S1 XOR S2 is true. Alright, okay. If odd number of variables is true, that means that one of S1 and S2 must have an odd number of true variables. Why is that? Well, think about it. If we have one of them to be true, not true, one of them to be odd, okay, the other one can either be odd or even, but let's say odd. If it's odd plus odd, well, that's even, and that's not the case because we said it had odd number of variables to begin with as a total thing, right? So it can't be that. So if it's odd, then the other one has to be even, so that summation is also in total going to be, odd. It can't be even and even either because, that's even. Again, all right, okay. So that means one of them has to be odd and one of them has to be even. Now, based on our inductive hypothesis, what did that mean? If it had odd number of variables, what that meant is that it's true, right? And if it had even number of variables, that means it was false. Okay, so one of them has to be true and one of them has to be false. Okay, we have our table from the question. if one of them is true and one of them is false, what are you always going to get? True, right? And that proves your case. If odd number of variables is true, then S1, X, or S2 is true. And remember how I said, like right after I explained the inductive hypothesis, that we must prove that S1, X, or S2 is true if and only if an odd number of variables set to true, and how I said if and only if is important. Well, in the two cases, we proved it this way, going this way, and we proved it going this way. And both cases, we just proved that this statement works for. Therefore, we just proved our inductive step. And because we proved our inductive step, that's it. That's the total. That's all of the question. Proved. Thanks for watching this video. I'll see you guys in the next one.